So we say we have two types of collisions, right? Two types of collisions. Okay. The first one was elastic collision. Right? Elastic collision. Okay. And for the elastic collision, we say the formula was mass 1 times V1 initial plus mass 2 times V2 initial equal to mass 1 times V1 final plus mass 2 times V2 final. Okay, that was for the elastic, and we did a few examples, right? Then we have a quiz on this. Then we have a test on this. This was the last problem on the test. Okay, now the next one, inelastic. Inelastic collision. Right? We already have the definition, right? We say it's the collision in which objects collide and some sum of mechanical energy is transformed into heat, right? Into heat energy. Right? And we wrote the formula, but let's rewrite the formula. Mass 1 times V1 initial, just like the same thing is the same. Right? This is like exactly the same. Plus mass 2 times V2 initial equals. Okay. Since it's inelastic, they stick together. Right? They stick together, so we say it will be mass 1 plus mass 2. See, they stick together. Right? Times one common velocity, just Vf. Okay. So they stick together, they have one common velocity. Okay. And we did not do any example, so let's do an example. Okay. Wait for you to finish so we could do an example. If an 800 kilogram sport car slows down to 30 meters per second to check out an accident scene, and the 1,200 kilogram pickup truck behind him continues traveling at 25 meters per second, with what velocity will the two move if they lock bumpers after a rear end collision? Right? So this is what we have every time or every day, everywhere, all over LA County. We have big traffic, right? Because people are so curious, right? If somebody has a little accident on the other side, everybody slow down to see instead of keep on going. So they create unnecessary traffic and sometimes even a secondary accident. Okay? It's really, really bad. I know, Vince. I know. Just mind your business, keep on going. But people are so curious in LA, you know, that they're always doing that. You don't see that on the East Coast. There's an accident, just keep on going. So there's no traffic. But here we have that. Okay? So anyway, so as you could see, the two cars now, after the accident, right? The truck is right on the bumper of the sport car, pushing it off the road. See, now they're moving as one. It's not elastic. See, they're not bouncing apart. They're stuck together, right? So we want to find the velocity that they're both moving at, the speed that they're moving together with after the accident. Okay. Right. So let's finish this quickly before our time run out. Right? This is a short day. So as usual, we're going to write the given. To write the given, let's go ahead and underline what we know. Okay? We have 800 kilogram for the sport car, which is going at 13 meters per second. Right? Then we have 1200 kilogram for the pickup truck, which is going at 25 meters per second. Okay? And we want to find the final velocity. Okay? So this one is pretty easy. Everything is together. Okay? So in our given, this is mass 1, V1 initial. This is mass 2, V2 initial. Okay, so let's write our given. Given mass 1, 800 kilograms. V1 initial 13 meters per second. Okay. On the other side, mass 2 to 100 kilograms. Remember, we like to write them side to side so we could easily see them. V2 initial 25 meters per second. Okay. Now we want to find V final. V final. Okay. Okay. So let's go ahead and write our inelastic formula. Mass 1, V1 initial plus mass 2 times V2 initial equal parentheses mass 1 plus mass 2, put that together, times the final common velocity. Okay, we plug in, right, mass 1, 800 kilograms, velocity 1, 13 meters per second, plus mass 2 to 100 kilograms times V2 initial, right, equals mass 1 plus mass 2. So that will be 800 plus 1200, right? 800 plus 1200 times V final. You guys see, this is much easier than the elastic one. So write this down. Take your calculator and let's finish it up, okay, before we could go. Okay. So those of you who have your calculator ready, okay, what is 800 times 13? Write your answer in the chat. 800.
We never know.
10,400. Okay. Okay. 1200 plus 25. $30,000. Thank you, Casey. 30,000. Okay. And 800 plus 1200 will be, thank you, Sophia. Thank you, Haley. 2,000. This is easy, right? 2,000. 2,000 V final. Okay. All right. Good job. Now let's combine these two together to see what we get. Will be 40,000. Right, let's add these two together. 40,400. Thank you, Casey. 40,400 equals 2,000 VF. Right. Now what do we do? How do we solve for VF here? Thank you, Jelisa.
Divide by 20,000.
Divide everything by 2,000. Thank you, Jelisa. Thank you. 2,000. 2,000. Okay. This cancel out. Okay, so divide and tell us what you get. Good job. 20.2. What is a unit, guys? You are forgetting your unit. We're looking for the velocity. Amen. Meter per second. We cannot forget about the unit. Remember? And I even asked on the test on Friday, what's the unit for velocity? Some people put Newton. Some people put kilogram. So, you're killing me. Okay? So we gotta get used to writing the unit all the time. Okay? Thank you, Maria. 20.2. So the V final, 20.2 meters per second. Okay? You see how easy this is? This is easy, right? So easy. So we will do more examples. I have not given you homework for a little while. Some of you asked me to give homework to help bump up the grade. So today after school, I will assign you homework. You guys can do this, right? This is easy. I want to assign you a few homework on this. Okay? And I will help you identify if it's elastic or inelastic. So this one is inelastic. I will give a few for elastic, okay? So that some people, you could practice and you can also earn credit to help your final grade. Okay? On the test, I asked for unit for momentum. Who remember unit for momentum? Who remember unit for momentum? Look, this is a momentum. What is the unit for this one?
Kilograms.
Kilograms is, see, this is kilogram. Is this momentum? Thank you, Sophia. Thank you, Casey. Is that kilogram meter per second? See, kilogram meter per second. Look, it's so easy when you see the formula. Okay, this is the mass, kilogram. This is the velocity, meter per second. So the unit is kilogram meter per second. This is the unit for momentum. The two together. Okay. So that was an easy 1 point. Many of you got it. And I also asked for unit for impulse. Impulse. Okay. Impulse. You guys remember, impulse is F times, who remember? F times delta. Who remember? Thank you. Delta T. Okay. What is the unit for F, the force? What's the unit for force? Help me out, guys. I'm helping you see how easy it is to find. What's the unit for force? Newton. Maria, you remember, right? Newton. Alisa, you remember, right? Now, what is the unit for delta T? Second. So this is your unit for impulse, guys. Impulse. This is in your note. I broke it down just like this. But here is what happened on the test. Many of you say unit for impulse is Newton. I say, are you kidding me? Newton is force or weight. Okay? Force or weight. That's the units for that. Okay? So be careful. All right. Time is up. You guys have to go to your next class. Make sure your name is in the chat so I could take proper roll. I will see you on Wednesday. Don't forget to do your homework today, okay? Tonight, I will send it. Bye-bye, everyone. Bye. Be good. Don't forget to wear your mask if you go out. Okay, Maria. Yes, if you get 75%, I will give you a B. Okay? If you want an A, I need 85%, my dear. You got to push it up, okay? So you got homework tonight, then you got a quiz on Wednesday, and you got a test on Thursday, okay? Do your best, and finger crossed, okay? Bye, everyone. Don't be late for other class. All right. If you go out, wash your hand, wear your mask, okay? Bye-bye. Stay safe. Thank you. Haley, on the test, there was a question where someone threw a tennis ball. Yeah, Mr. Arnold. And they come back. And you forgot to change the sign. Remember? It said it bounced back. The ball bounced back into the opposite direction. Right? So that will be, I think it was 40 minus. So it's double minus, Haley. Okay? That example is in your notebook. The ball was going, and then it hit the racket, and then moved to the other direction. So it's double minus. So it should be like 40 minus negative 14. Okay. Yes. So the two velocity add up. That's what that problem was about. Okay. All right. Bye-bye. You too. Thank you. What this means is core 1 and core 2 collide, and instead of bouncing, it's not bouncing because it is not it's not elastic. It is inelastic, right? So there's no bouncing. So they're moving together. So yes, they have a shared final velocity. They're moving together. It's almost like the truck come hit the car and just push it. So they're moving together, right? So yes, they have one final shared velocity. Okay. Vince, of course, you're going to have both, right? You're going to have definition and you're going to have actual problem. Okay. You'll have both on the test. Example. Okay. Example 1. Let's see one example with let's see if it's elastic or inelastic. Okay. So Toby and Chubby. What question can be asked? What is missing here? What information is missing? No, that could not be the question. How do you hit a parked car? Yeah, that's a question, but that's not going to be the question to solve. After the collision, okay? After the collision, what question can they ask us? What is missing from the problem? Or what happened after the collision? What happened after the collision? What happened? Thank you, Jackie. You see, how far did you end up going? Exactly. That is what's missing. If Jackie's car was just parked and they come and collide with her car, of course, her car is no longer going to be parked still. It's going to be moving. So we need to find the speed at which Jackie's car is dragged across the floor or the road. Okay? So how fast is Jackie's car bumped across the floor? Bumped across the floor or the road. Okay? Dragged, yes, dragged or bumped. Okay? But right now, since it's an amusement park, it's not the road, right? It's that little space that they have, right? So it's like a floor. So dragged across or bumped across, okay? All right, everybody copy? We're going to try to write the given, and then we're going to try to solve it, okay?